Good morning to all. Today we are going to learn about the atomic theory of matter. That means how the atoms are combined or how the atoms are electrons are com- electrons remain in different shell in an atom. That means all matter, whether element, compound or mixture, is composed of small particles called atoms. There are some little bit problems in this statement. However, that is the basic of our atomic theory, which has been given by John Dalton. And this is the photo of John Dalton. He was born in 6 September 1766 and died on 27 July 1844. That means though he has earned or he has given very good statement or he contributed a lot to the science, however he did not receive the Nobel Prize because he already died before the starting of Nobel Prize. Nobel Prize has started from 1901 and he died 1844. However, we know John Dalton as a great chemist or great scientist. So though John Dalton given some of the mistakes, we will learn also today what are the mistakes he has given in the postulates of Dalton's atomic theory. However, that is the basic of our atomic structure or periodic table. Let's see what are the postulates of Dalton's atomic theory. That means what was the main agenda that he has given against or supporting the atomic theory. All matter is composed of indivisible atoms. I have given two different color in two different words. Indivisible, that is one of his mistakes. That means in that time that was okay, because he has given the postulates in the 18th century. That was very old, and that time we didn't have very good efficient or very good research facilities. However, he has given the idea. What was his mistakes? He has mentioned that all matter is composed of indivisible atoms. Indivisible. But in last class already I have taught you the discovery of electron, proton and neutrons. That means an atom can be divided into several particles. I have mentioned just few of them, which are fundamental particles. However, you may study it or you may know that an atom can have more than 200 particles, but they are very short time, they exist very short time. But most of the particles or most of the fundamental particles what we have mentioned, electron, proton, neutron, these are very long time exist, they exist for a long time. So we have studied only three, but maybe I can give you some other names: meson, neutrino, antineutrino. These types of, there are several other particles which are also available in an atom. So Dalton has given the idea which was in more than 200 years before, more than 250 years before. That time there was no good research facility what we can do right now. So at that time he was okay, but science is developing day by day. Therefore, when we get something or when we know something more, that time we can recover or we can correct our ideas what we had. So all the matter is composed of indivisible atoms. Okay, atoms, that is another word. He has used atoms for all the matters, but we now know atoms and molecules, or two different atoms combined to give a molecule. So he could not show the difference between atoms and molecules. However, he has used these words atoms for the first time. That is, so that atoms word he wanted to understand or make understand the element, the smallest part of element. However, he has mentioned that atoms for all the matters, but he really wanted to mention that the atoms for the smallest part of an element. In the next postulates, in the next slide, I will show you. An atom is an extremely small particle of matter. Actually, today we know an atom is an extremely small particle of an element that remains its identity during chemical reactions. That is fine. So just he has considered that it should be an element, but actually he has mentioned as matter. Matter means that it can be element or a compound that retains its identity during chemical reactions. So that is also another difficulties, later I will show you. Retains its identity during chemical reactions. In general it is okay, but if we go further for a study, or if we want to know, in that case we will say that is also little bit difficulty. However, in general this is okay. Sorry, another one have given. An element is a type of matter composed of only one kind of atom. Here you can see, you have he has mentioned a small particle, for atom, but he also mentioned about the element. An element is a type of matter composed of only one kind of atom. So if he know the element, then he could give the idea about the atom, or here he could use the element. However, as far as he has given the idea from his own idea, so that is okay, because at that time they could not do very deep research or very sophisticated research, because they didn't have so tough or so very so qualityful instruments. Each atom of a given kind having same properties. This is another difficulties, or this is another mistakes what he has given. And nowadays we can have another idea that one element can have different kinds of atoms, which are called as isotope. In later I will discuss a little bit more with examples. A compound is a type of matter composed of atoms. That means he has shown the difference between element, compound and matter. However, when he mentioned about the atom, just he considered the matter. That is little bit dilemma. A compound is a type of matter composed of atoms of two or more elements. That means he has mentioned that when a compound is formed, that can be combined to two or more elements. That is, we know nowadays this is also perfect. That means when a compound like as water, when water molecule is formed, two hydrogen atoms and one oxygen atom combine to form a molecule, water molecule. That means a compound. However, he has mentioned that a compound is a type of matter composed of atoms of two or more elements chemically combined in a fixed proportions. That means the ratio. He mentioned that the relative numbers of any two kinds of atoms in a compound occur in a simple ratios. Simple ratios means 1:2, 2:3, 3:4 or something like this. That means these types of simple ratio. In water molecule, two hydrogen atoms combines with one oxygen atom. Therefore, the ratio is 2:1. Or if you consider in the other way, carbon dioxide, one carbon atom and two oxygen atom combine to form carbon dioxide. So the ratio is 1:2, like this way. So this is the simple ratio. This is very okay. But nowadays we can find some compounds having the ratio can be fraction, like as if you are familiar with the iron 2 and iron 3 oxide. When these types of compounds are formed, in that case you will see that Fe2O3, Fe3O4, this is one compound which is rust. That means after the reaction between metal and oxygen, it forms iron 2 oxide and then forms iron 3 oxide. So when these iron 2 and iron 3 oxides combine, they form Fe3O4. So if you consider the ratio 3:4, so if you divide the number, in that case it becomes a fraction. So however, we can consider it as a 3:4. This is another ratio. This is simple ratio. However, if you divide the numbers, then in that case you are getting a fraction. So it is one kind of simple ratio. If you put all the numbers, whole numbers, that is simple ratio. However, in actually we can say this is a fraction. So a chemical reaction consists of the rearrangement of atoms present in the reacting substance to give new chemical combinations present in the substances formed by the reaction. That means in any reaction we may have several atoms, and in the reactant portion, when these reactant atoms combine each other, then they can form different other component. That is the main function of a reaction. In general, like as when a hydrochloric acid molecule reacts with sodium hydroxide, that means hydrochloric acid is composed of hydrogen and chlorine atoms. On the other hand, sodium hydroxide is composed of sodium and oxygen and hydrogen. So there are 5 different atoms in the reactant. Now when the product water and sodium chloride is forming, in that case what happens? The water molecule, that means 2 hydrogen and 1 oxygen, and sodium chloride, 1 sodium and 1 chlorine. These atoms are combining. So first their rearrangement is going to be distorted, or the bond between the molecules are broken, and then these bonds are, or these atoms are rearranged, so that we are getting new elements or new compounds. But one very great mistake he has mentioned: atoms are not created, destroyed or broken into smaller particles by any chemical reaction. That is a really great mistake. But still I would say in that time that was okay, because that time we didn't know about the radioactivity. The radioactivity is very new. So just few, maybe less than 100 years we know about the radioactivity. So when he has given this idea, that time it was okay. From radioactivity, what we know, we can generate new atoms. We can generate or we can create new atoms, so that we can mention that atoms are not created or destroyed. This is not a good idea or not correct exactly. So later I will show you. And also in last class I have mentioned that when a beryllium atom is heated or attracted by helium, that means that is alpha particle. So when beryllium atom is attracted by the helium or alpha particle, in that case we can get a carbon atom and a neutron. That means in that reaction we have shown that the new element or new atom can be created. And previously in the reaction, what we had? Helium and beryllium. These two atoms already destroyed to create another new atom, carbon. So here he has mentioned some very good idea, though it has some mistakes. However, this idea is one of the greatest invention or discovery in science and chemistry, because based on this idea the recent day chemistry is developed. So from his idea we are developing the science day by day, or chemistry or molecular structure, many more other things. Now what are the mistakes? Already I have mentioned during the postulates. However, just little bit more, atoms are divisible. So he has mentioned that atoms are not divisible or atoms are indivisible. But nowadays we know we can get electrons, protons, neutrons, meson, neutrino, antineutrino, several other fundamental particles and also transit particles. So these particles can combine to form atoms, and also did not show any difference between atoms and molecules. He has mentioned about the matter. For atom he has mentioned the smallest part of matter, which is called as atom, he has mentioned. However, nowadays we know the smallest part of an element is known as atom, and smallest part of a compound or a smallest part of a matter is known as compound or molecule. So he did not show the difference between atoms and molecules. All the atoms in an element are not always same. He has mentioned that all the atoms in an element are always same. That means he had no idea about the isotope. Later I will show what are isotopes, and new atoms can be created in a reaction. As already I have mentioned that he has mentioned that no new items or new atoms can be created or destroyed in any reaction. So from his reaction, what I have mentioned in the reaction for neutralization reaction or reaction between hydrochloric acid and sodium hydroxide, he has mentioned that these types of reaction normally this is very common and this is real. That means in that type of reaction or in general reaction, no atoms are created or destroyed. But in the radioactive decay or radioactivity or some radioactive reactions, some new atoms can be created by destroying some elements or some atoms. So we know new atoms can be created in a reaction. Now what are the isotopes, isobar and isotone? Dalton has mentioned that all the atoms in an element have the same properties, and different element or different compound will have different properties. So but nowadays we know that an atom or in one element, in an element we can have different types of atoms. How it is possible? We know that hydrogen atom has one proton and one no neutron, just one proton and one electron. That is very common. We know these types of atom, but scientists have found several other, at least two other isotopes of hydrogen, which is known as deuterium and tritium. Generally we call hydrogen as protium, and which consists of one proton, one electron. It has no neutron. But protium that means hydrogen, and deuterium, here you can see this is the deuterium. Deuterium has one proton and one neutron, so the mass number of deuterium is 2. And we have another isotope of hydrogen, that tritium. In that case the mass number of tritium is 3. Then how it is possible? In that case the hydrogen, that means that tritium has one proton and 2 neutrons. So protium, deuterium, tritium, all of them are atoms of hydrogen, but still they have different properties and different atomic number. and they have also different chemical properties also. They can, so we know that an element can have different atoms with different properties. So like as hydrogen and this carbon atomic number 6, but this carbon has 6 neutrons, this carbon has 7 neutrons. So the mass number of this carbon is 12 and 13. So what is the isotope? Atom with same number of proton. Same number of proton, what does it mean? The same element. It can be hydrogen, oxygen, nitrogen, carbon, or many other elements. Most of the elements in the universe has several isotopes. Most, almost. Maybe some of them have very few, but some of them has less, many. So isotope, most of the elements. So from Dalton's theory or Dalton's postulate, we know that atom with same atom or element, all the element or all the atoms in an element are same, and their properties, chemical and physical properties, are same. But nowadays we know the atoms in an element can be different in physical and chemical properties. So we know about the isotope. Now what is isobar? He has mentioned that the same different element or different compounds will have different properties. But nowadays we know that different atom can have similar properties or same chemical properties or same properties. Atoms of different element having same mass number. Here you can see we have several isotopes named sulfur 40, chlorine 40, argon 40, potassium 40, calcium 40. So here you can see all are different elements, all are different atoms having the same mass number, 40, 40, 40, 40, 40 for all of them. So Dalton mentioned that all the elements, all different element have different chemical properties or properties. So but nowadays we can have the different elements or different atoms can have similar characteristics. Here you can see all the atoms have different atomic number, that means different proton number, sulfur 16, chlorine 17, argon 18. So all the elements have different atomic number, which represents that they are of different elements. However, they have same mass number, that means their neutron numbers are different, so that overall the mass number can be same for all these elements or all these atoms. Therefore the idea what Dalton has given has a little bit mistakes. So nowadays we know that isobar, that means the different atoms of different elements can have the same mass number, so they are known as isobar. Even we have another properties which is known as isotone. Isotone, sometime you may be get confused, isobar and isotone. This is very easy. Remember, for isotone the number of neutrons are same, and for isobar always remember the number of mass number is same. So mass number is same, and for isotone the number of neutrons, that means isotone and neutron. Remember these two words that are very similar. So isotone and neutrons. So for isotone you need to remember that the number of neutrons in two different or more elements or two different or more atoms are same. So if different atoms or different elements have same number of neutrons, these are known as isotone. That is also against the idea of Dalton's. That means he has mentioned that two different elements cannot have similar properties, or they are different. But here we can see that chlorine 37 and potassium 39, both of them have 20 neutrons. So they have some similar properties. Therefore chlorine and potassium 37 and 39, they have 20 neutrons, so they are isotone. So this is against the idea of Dalton. Now we will learn about the electronic configuration of atoms. So what is electronic configuration? Electronic configuration of atoms, that means how the electrons will arrange or rearrange or distribute around the nucleus. The electron configuration of an atom is the representation of the rearrangement of electrons distributed among the orbitals, shells and subshells. Still I didn't mention about these shells, subshells or orbital, whatever. Later I will show you one by one. The electron configuration of an atom, that means how the electrons are distributed among the neutrons or nucleus, because we know for an atom the nucleus is composed of neutrons and protons. That means the nucleus is at the center and only the protons and neutrons are inside the nucleus. So the electrons are surrounding the nucleus, but that is not in certain region. The electrons can occupy a specific region which is known as shell or energy level. So where the electrons will occupy, so electrons are remaining outside the nucleus, and this can be in different position and it can have different area. So the electrons will reside in different area, and that is known as electron energy level or shells. According to Rutherford Bohr model, electrons are thought to occupy fixed circular orbits. So Rutherford and Niels Bohr, they have given the idea that electrons will occupy at a certain position and that will be fixed. That means if you consider outside there is one circle, in that case either in the top, in the bottom or in the left or right, these types of arrangement they have considered. However, electrons actually do not exist in a certain place or in a certain specific place. It do not exist. So it continuously rotate in an orbit. These orbits are known as energy level or shells. However, nowadays we know that the electrons reside in the orbit. However, the availability or the electrons where they exist, it has certain area or region, or more they exist more time in certain regions in the orbit or in the shell, that are known as subshells, and later we will discuss it. So the Rutherford and Bohr mentioned that electrons are thought to occupy fixed circular orbits around the nucleus of an atom. The electrons with the lowest energy levels occupied the lowest orbits. That is okay. So there are many orbits or many shells in the atom outside the nucleus. But how the orbits are filled? The electrons having the minimum energy will fill the first shell. That means it will remain closest to the nucleus. The electrons with the lowest energy levels occupied the lowest orbits. Electrons with the higher energy levels would occupy higher orbits. That means the electrons having more energy will occupy in the higher energy level or outer or further from the nucleus. Here you can see that orbit or the energy levels. In the Rutherford model of the atom, electrons occupy electron shells, each of which is located at a certain distance from the nucleus. So this is the first shell, second shell, third shell, fourth shell, fifth, sixth, seventh. So the distance from the nucleus or center to the shell or energy level is fixed. So from here, and all these levels are discrete. That means this level do not overlap to this level, or even this level do not overlap to this. So these are discrete. So energy of these levels are discrete and separate. But there is some possibility when an electron residing in a certain energy level, if the electron gains some energy by somehow, if we supply some energy or any other way. So if an electron in the lower orbit or lower energy level, it gains some energy, and if the energy of that electron is exactly equal to the energy of this, in that case the electron can jump from the lower energy level to the higher. In the similar way, if any electron in the upper orbit, here or here anywhere, if an electron in the upper energy level reduces its energy, and if the energy of the electron, maybe this electron, if the energy of this electron is just equal to the energy of this orbit, then this electron can come to this orbit or this energy level by radiating some energy. So here we have mentioned that when the energy of this orbit or these energy levels are fixed, so when an electron residing in a certain orbit or energy level, they do not exist in a certain place. They continuously rotate around the nucleus, and these are known as orbit, and the energy of that orbits are fixed, and by gaining some energy it can jump to the higher energy level, or by losing some energy it can come to the lower energy level. Okay, and another thing, these energy levels can be represented by different shell, K, L, M, N, O, P, Q, like this way. Just if we represent a K shell, then you will easily understand that this is the first shell or first energy level. So similarly, if we represent something like as M, that means M shell, that means this is the third shell. So this is the representative letter representation. So this is the number representation, or you can easily understand the for n equal 1, 2, 3, 4, 5. These are the when the value of n is increasing, the distance from the center of the nucleus is increasing, and the energy of the residing electrons in the further shell is increasing. So the energy of the outermost electrons, outermost shell, maybe this one or whatever, just based on the number of electrons in an atom, the energy of the outermost electron or outermost shell is the maximum, and energy of the closest or the first shell is minimum. Okay, atoms tend to assume to the most stable configuration and the lowest energy level possible. That means when we consider the electronic configuration of an atom, always try to remember that the atom will be in the minimum energy level. The minimum energy level, how it is possible? They will fill the electrons first in the first shell. So when the electrons fill the first shell, and if there are any other more electrons, in that case the electrons can go in the further shells, second shell, third shell, or any other. So atoms tend to assume the most stable configuration and lowest energy level possible. For that reason, the electron shell in an atom are usually filled in the strict order, starting with the lowest energy level. That means first shell will be filled first, second shell, third shell, and then later on. But Then one other thing very important, the number of electrons. Number of electrons in a shell or in an energy level is determined by certain formula. Maximum how many electrons can reside in an orbital or in an orbit or a energy level or shell is determined by 2n square, where n is the number of shell. Number of shell, that means what I have shown here, this is the value of n equal 1 2 3 4 5 6 7. So for these types of, in any shell, in any energy level, how many electrons can reside, that is determined by the number of shell, 2 into n square, this formula. So for the first shell, how much electrons can reside? So 2 into 1 square, so that will be only 2. And then for second shell, the value of n is 2, so 2 square, that means 4 into 2, that means 8. So in the second shell you will have 8 electrons. This is the first shell, this is second shell. So in the second shell you can have maximum 8 electrons. And if these electrons, if it is filled, that means if it follows the 2n square formula and maximum 2n square electrons in a shell, then the electronic configuration of that atom or element is more stable. Therefore this is the stability formula you can consider. That means how many electrons can reside in an orbit or in an energy level. This is 2n square and n is the number of shell. Okay, this is the periodic table. And if you know the electronic configuration of an atom, you can understand the periodic table or position of the periodic table. Or other way, if you know the position of the atoms or elements in the periodic table, then you can guess, or then you can have idea regarding the electronic configuration. Just this is one other way, or vice versa. Let us consider for this periodic table, in this shell, this is one group. So for periodic table you need to remember some other things, how many periods and how many groups we have, and how the electrons are how the atoms are kept in the periodic table. So that is very fundamental. So that will be relative, that you will know by knowing the electronic configuration where the atoms will be in the periodic table. So just remember, or here you can see how many groups or how many here you can see how many periods we have. This is 1 2 3 4 5 6 7. We have 7 periods in the periodic table. So in a periodic table you have 7 periods. Till today, here you can see only 109 elements. Actually nowadays the scientists have found 118 elements, but all of them are not given in the periodic table, because all of them we did not know, or we do not know the electronic configuration. So where the elements will be exactly, this is not known. So after that these elements are not put in the periodic table. So in the periodic table the elements or atoms are arranged based on certain property. Here you can see how much groups we have. We know we have 18 groups, 1 2 3 4 5 6, like this way we have 18 groups. But in some of the books or some of old books you may have 8 groups, but actually nowadays we also consider these are separate groups. So totally we have 18 groups nowadays. That means we know this is 1 2 then 3, 4, 5, 6 like this way up to 18. So just remember, in the periodic table you have 7 periods and 18 groups, and based on the number of electrons in the outermost shell, the elements are arranged in the periodic table. How many electrons reside in the outermost shell? To understand that, you must need to know the electronic configuration or how the electrons are arranged in an atom. So first, the position of an element in the periodic table tells us a lot about the electron configuration. Already mentioned that if you know the position of an element in the periodic table, then you can understand that what is the electronic configuration of that atom. So let us consider you know the position of sodium atom. So in that case, in the periodic table, if you know the position in the third shell or third period and in the first group, that means if you know the position of the element or atom in the periodic table, then you can have the idea about the electronic configuration. Outermost shell, in the group 1, all the elements have 1 electron in the outermost shell. So if you know the position of the element in the periodic table, you know the electronic configuration. It may be difficult to know exact configuration from the outermost shell configuration. However, if you know exactly the position of the element in the periodic table, that means in which period and which group, if you know, in that case you can easily understand the configuration, how many electrons in the inner shells or inner orbits exist. So if you consider for sodium, then sorry, if you know the position of sodium in the periodic table, in that case you can understand that sodium is in the first group. In the first group, that means it has outermost shell 1 electron, and this is in the third period. Third period, that means it has first shell filled, second shell filled, and third shell. Third shell has 1 electron. So if the first shell and second shell are filled, then what happens? In the first shell it has 2 electrons, in the second shell it has 8 electrons. So overall you can find out, or overall you can understand that sodium atom has first shell filled, that means 2 electrons, in the second shell 8 electrons, and in the third shell it has only 1 electron. So you can understand that sodium atom has 2, 8, 1, this configuration for the electrons. So the position of an element in the periodic table tells us a lot about its electronic configuration. The table itself is divided into rows and columns, already I have mentioned. So how many columns and how many rows we have? We have 7 periods and 18 groups. And this is the end of today's class, and in the next class I will discuss about the exact electronic configuration and orbit, orbital, and different other things. So if you have any questions or comments regarding this, you are welcome to ask.